Okay, so in this video, we're going to learn how to design databases. But before we can get to that point, we need to understand a few things. So first, we need to understand what tables are. For this part of the video, we're going to spend some time looking at my UCLA lecture notes. We also need to understand what data normalization is. In short, we need to avoid duplicating data when we're designing our tables. As a result, we're going to have to understand what relationships are when creating tables. So we need to understand one-to-one, one-to-many, many-to-one, and many-to-many. And finally, we're going to end the video with a practical example. And here is where we will learn some basic SQL. So this is where we will learn about primary keys or foreign keys, or more generally put constraints. And we'll also look at this object relational mismatch. So this is where we will learn about ORMs, or object relational mapping frameworks. Okay, so enough with this intro, let's just get right into it. So let's say we want to keep track of all our friends. And let's say that this is the information that we want to keep track of: name, phone number, birthday, type of phone, social security, favorite food, and so on. We also want a way to be able to search for a particular friend in more than one ways, right? We want to be able to search by name, maybe by birthday, maybe by social security. Okay, and so this group of related data is referred to as a record. So here we have a friend record. So each record has a bunch of fields, right? Like name, phone number, birthday, type of phone, social security, and so on. Okay, so now if we have a bunch of records, collectively, we refer to them as a table. And it's important to note that some fields will have unique values across all records. And so this is important because this type of field is useful for searching and finding a unique record. So a field like social security number that has unique values across all records is called a key field. And when we're designing databases, there's a number of ways to achieve unique values across all fields. One is by using the primary key constraint, and we'll get to that when we're designing our database, right? So here our social security field is a key field since every record is guaranteed to have a unique value for this field. So how can we create a record in C++? We can use a struct and define the fields or properties that we want to include in a record. Okay, so now that we have a record, how can we create a table in C++? So the answer is that we can use an array or vector. And you can think of a vector as being more or less the same as an array. And this is what the syntax looks like. We have a vector of type student followed by the name of our table. And here we just call the table. Okay, so now that we have a table, how can we search this table or this vector for a particular field value? Let's say we want to search by name. So what we can do is write a very naive function to allow us to search for a particular name. And it looks something like this. It's just a for loop iterating over our vector, looking for that particular name. If we find it, we return the student. Otherwise, we return -1 to indicate that we have not found the student. And we can write another function to search by phone. What we can do is take it a step further and package all our code into a class. And the code we are seeing in these slides is not that important. What's important is understanding how one might go about building a database naively. Okay, and so in the table of students class, we used the vector to hold our table. And then we wrote a simple function which performs a linear search to find students by their name or phone. This is a valid table. The only problem that it's very slow to find a student. How can we make it more efficient? What we can do is we can sort our vector, right, alphabetically. So we'll go ahead and do that. And now we can do a binary search to quickly locate a record based on a person's name. But every time we add a new record, we have to resort the whole table. Right, and so if we sort our vector by name, it means that we can't search efficiently by other fields like phone number or ID number. So one thing that we can do is store our records in a binary search tree and organize it by name. And that will look something like this. So now we can quickly search for any given name, but we still have the same problem as before. We still cannot search efficiently by ID number or phone number or any other field that we want to search by. So what can we do? What if we create two tables, right? The first one ordered by first name and the second ordered by ID number. So this works, but now we have two copies of every record. And this is not good because it's a waste of space. Okay, so our first approach didn't work. Our second approach didn't work. So what can we do? Okay, like before, we will use a vector to store all of our records. Next, we'll add a data structure that lets us associate each person's name with its corresponding slot number in the vector. So we'll add a map, and behind the scenes, this will create a binary search tree for us, and it will look something like this. So this second data structure lets us quickly look up a name and find out which slot in the vector holds the related record. So if we take a look at our root node, we see that its corresponding slot is 5, and we can use that information to find our record in our vector. Okay, so now we can add another data structure to associate each person's ID number with their slot number as well. We create another map, and behind the scenes, we create another binary search tree, but this binary search tree is ordered or sorted by ID number. So this data structure lets us quickly look up an ID number, find out which slot in the vector holds the related record. Okay, and so this is important because these secondary data structures, these are referred to as indices in the world of databases. These indices are important because they let us efficiently find a record based on a particular field. And the good thing about this is that we can have as many indices as we need for our application. If we wanted to, we can add an index for phone number as well. Okay, so now that we know what these secondary data structures are, namely indices, how does the add student method look like now? So I'm not going to go through the code. It's pretty straightforward, but essentially what we're doing here is that anytime we add a new record to our vector or to our table, we need to make sure to update all of our indices, and we'll see that played out in a bit. Okay, so every time we add a new record to our table, like Wendy, we need to make sure to update our indices as well. So the next thing we need to do is update our first index. So what we do is we need to traverse our tree and find out where to place Wendy. So we'll go ahead and do that. Doesn't go here, nope. Doesn't go here, nope. And we found its corresponding spot. So we'll go ahead and add a new node. And similarly, we need to update our second index, right? We do the same thing. We traverse the tree and figure out where to place this new. So we'll go ahead and traverse the tree and we find where to add the new node. Anytime you delete or update a record's searchable fields, you need to update their corresponding indices. So let's quickly walk through an example. Okay, let's update slot 6. Let's change the name from Wendy to Aggie. So now we have to update both of our indices if necessary. So let's go ahead and update our first index. Now this node will be placed somewhere over here. And similarly, let's check if we need to update our second index. And for the second index, we don't have to update our tree because we didn't update the ID number. So we're good here. And so these slides are important because it helps build our intuition and understand how someone might build a database. And as it turns out, databases use exactly this approach to store and index data. And so while these examples used binary search trees to index the table's fields, you can use any data structure you want. You can use a hash table if you wanted to. Let's go ahead and use a hash table. Let's replace this first index, which is using a binary search tree, with the hash table. And it looks something like this. So now we can search for a name in constant time. So if we can search for a name in constant time, why not just use a hash table for all of our indices? Well, one of the reasons is because hash tables store the data in an essentially random order. While a binary search tree is slower, it does order the key fields in alphabetical order. But what if we want to print all students alphabetically by their name? If our index data structure is a binary tree, it's pretty straightforward to do. If we index it with the hash table, we need to do more work to do the same thing. So in other words, we need to understand how our table will be used to determine how to best index each field. So for example, use a binary search tree for the name field so you can print people's name in alphabetical order. Use a hash table for the phone field if you just need to search quickly. Okay, so now that we know what a table is and what indices are, the next thing that we need to learn about is data normalization. In other words, how can we create tables without duplicating the data? So if we head over to YouTube, I'm going to show you a quick snippet from a video which captures this idea pretty well.
So let's say you're opening your own online store for something like specialty cat accessories, and you want to be able to keep track of all sorts of information surrounding your sales. Most people would just open a spreadsheet and start putting in things as orders come in. Maybe it looked like this. Mary's our customer, she buys a cat leash, and you capture all this information. And you just record this information for each of your customers that trickle in. But maybe later Mary buys something else, like 3 cat leashes, and at this point she's moved to a bigger place to have room for all her cats, so her address is different. Now you've got redundant information, some contradicting values for your customer's address, and if your specialty cat store got enormously popular, these issues would just escalate. Mary calls to ask about one of her orders, and when you pull up her information, you get 3 different addresses, all these disorganized orders, and you're not even sure you're looking at the correct customer because there are 3 different Mary Johnsons in your spreadsheet. You could see how this might lead to a messy situation. Shipments could get sent to the wrong place, customers might get mixed up, and the wrong products could get sent to the wrong people. So how would you resolve this? Instead of having just one massive spreadsheet, you'd separate the information into different bite-sized tables. So with our cat store, for example, you might start by creating a table that lists all of your customers, and then a separate table that lists out all your products, and then another table that records each of your orders. This separates the data you're pulling in a much more efficient way. So here's what your customer table might look like. You can see we've got Mary again, but now she won't be repeated into several different rows. Any change to her address, contact info, or even name can be updated in this one consolidated place. The product table would have all your cat accessory inventory. As you add or remove items, this would be the one place where you'd make those changes, and orders would keep track of every single sale you make. Now these tables, although separate, have connections to one another, and it's these connections that form the database.
So this is what data normalization is all about, is figuring out how to design our tables and how to create these relations between tables. Okay, so now that we know a little bit more about data normalization, we can move on to bullet point number 4. And here we need to understand these relationships when creating tables. We need to understand one-to-one, one-to-many, many-to-one, and many-to-many. Okay, so let's quickly go through each of these items. And before I forget, I want to show you this PDF on data normalization. I forgot where I found this PDF, but I'll make sure to include it in the repository and upload everything to my GitHub. So anyways, so the one-to-one relationship is pretty straightforward to describe. We can think in terms of users and accounts. So here, only one user can have one account. So one user maps to exactly one account, and one account maps to exactly one user. A user can have multiple accounts, and an account cannot belong to multiple users. Okay, and so for the one-to-many, this one is a little bit more involved. Right, so if we head over to the book that I've been reading to learn more about database design and look at this diagram and ignore all the other tables for now, except for the users table. And consider the positions table, education table, and contact info. And so this can be interpreted as a one-to-many relationship. So one user maps to many different tables. So by just using the user ID, we can find a lot of things about this individual. We can find about their position at work, we can find about their education, and we can find more about their contact information. And so this arrow here represents a one-to-many relationship. Okay, and to explain the many-to-one relationship, we can think of the following. Many people live in one particular region. And then for the many-to-many relationship, we can think of the following example. We can think of it this way. We can think of a user having favorite teams. So a user can have multiple teams that they like, right? Team 1, team 2, let me move this over, and team 3. And conversely, one team, so for example, team 1, can be favorited by multiple users. Actually, let me move this over here. So we can have, let's say, user 1 likes this team, user 2 likes this team, and user 3 likes team 1. Okay, so now that we understand tables, indices, data normalization, and these relationships, now we're ready to jump into the practical portion of this video. I don't want this video to be too long, so I'm gonna go ahead and use HonoJS. Okay, and so before jumping into the code right away, we're going to use a website that's going to help us design our tables. So after we design our tables with the diagram, then we're going to use SQL to model those tables. And as we're building out the syntax to create these tables, we'll learn about primary keys and foreign keys, or more generally put, constraints. Once we're done creating our tables in PostgreSQL, we're going to use Hono and start building a simple backend. Then we're going to install an object relational mapping framework. And so this is where we'll take a look at this object relational mismatch. Okay, so this is the website that I will be using to design our database. So I've gone ahead and written most of the SQL, but I want to go through the process of designing the database with the user interface. Right, so if we take a look at this SQL file, I have most of the SQL that I need to get my database up and running. One of the reasons why I'm making this video is because at work, there aren't many opportunities to design databases from scratch, right? So when it comes to designing databases, it's very domain specific, and it really depends on how you're going to be querying your data and how you're going to be using your data, how you're going to be visualizing the data if you want to visualize it. So the way I went about it, I thought about this matches table. So maybe think about your end result. So for me, for example, I wanted to visualize matches first. So for now, only focus on the name and forget about all this other metadata. Anyways, and so once I figured out that I wanted to visualize matches, then I started to ask myself, what information do I need, right? I'm going to need a match ID. I'm going to need a match date. I'm going to need the home score, the away score. I'm going to need a league ID. I'm going to need a home team. And I'm going to need an away team. So once I figured this information out, I started to work backwards. The next table that I designed was the leagues table, and it looks something like this. And as I was figuring out what data to keep track of, I found that I was going to need this country code field. So then I went ahead and designed a country code table. Anyways, with all of that in mind, I am going to go ahead and minimize this window and bring in this window. Okay, so now it looks like I need a country codes table. So I'll go ahead and add that table. I'll call it country codes. I'll add it. And for the ID, I'll go ahead and change it to country code instead. And for right now, when we're creating these tables and adding new fields, let's just ignore the metadata, since the purpose of this diagram is to only visualize the relationship between our tables. Once we start writing the SQL, then I'll focus more on this, the metadata. Anyways, moving on. Okay, and so our country codes table also needs a country name field. So I'll go ahead and do that. Country name. The next table that we need is a leagues table. I'll rename ID to league ID. I'll add a league name field. I'll add a country, okay, and so this is where, let me see, this references country codes. And so this is where foreign keys come into place. Okay, and so now I need to add a country code field. Okay, so now that I added a country code field to our leagues table, we know that we have a country codes table. So now we need to create a relation between these two tables. In other words, the country code value must be one of the values that live in this country codes table. Okay, and so to do this and to express this relationship, I need to create a foreign key. Okay, and so to do that, I'll just go ahead and create this foreign key, right, and link it to country code. Okay, got to do that again. There we go. So country code is a foreign key, and that value exists in our country codes table. Okay, so now I have to create a teams table. I'll update this field to team ID. I'll add another field, country code, and I'll add another field, league ID. Actually, I don't need this field because our leagues table will contain that information. Yeah, so I actually don't need this field, so I'll go ahead and remove that. And I'll make sure to remove that as well in my SQL. I do need a new team name, so I'll go ahead and add that field, team name. So again, if we take a look at this teams table and look at the league ID field, we know that we have a leagues table. So this means that league ID is a foreign key, meaning that the values for our league ID field live in our leagues table. So again, to express that relationship, we do the following. Just go ahead and create a foreign key. And now I need to connect it to league ID. Okay, and finally, I need to create a matches table. And we need to add the following fields. Match ID. We need to add match date. We need to add home score. We need to add away score. We need to add home team. And we need to add away team. And I realize I just have another mistake here. So we do not need to include league ID because home team and away team reference our team table. So these two are foreign keys, and we need to express that relationship once more. And to do that, we'll go ahead and select team ID, create foreign key, connect foreign key to home team. We'll do it one more time, and away team. Okay, so now we're ready to jump into the SQL, and we're gonna write the SQL one line at a time. And so before moving on, I just want to point out that one, I don't have that much database experience. I do have a lot of experience with writing SQL queries at work. And as you saw, I made a few mistakes here and there, but I was able to catch them. The important thing here is that you keep moving along. It's important that you make progress and that you don't dwell on every single issue and try to make this application perfect. Just do the best that you can with the resources available to you. Also, before moving on, I have a bunch of resources listed up here that help you with learning how to design databases, and I'll make sure to include them down below in the description. And I'll also make sure to order them logically from top to bottom so it doesn't feel like you're just reading random bits and pieces of information here and there. Okay, so now we're ready to actually build our database and start writing some SQL. Before we can continue, you need to install PostgreSQL if you don't have it. I'm not going to go through that process. You can figure that out on your own. So once you install Postgres, the installer should install this app, pgadmin. I'll go ahead and launch that. And when I first installed it, I don't remember if I had to set a password. You might, I'm not sure. And again, you can figure that out on your own. Okay, so now that I have the pgadmin application up, I'll go ahead and click on servers. And if you look at my database tab, you can see that I already have a few databases. So I'll go ahead and right click on database and create a new database. And I'll go ahead and call it footy. And then I'll go ahead and click save. Okay, so now I need to start creating my tables. So I'll go ahead and right click on footy and bring up the query tool. And the syntax looks something like this. Create if not exist table users. Okay, so to start, we need to keep track of a user ID. We need user email and we need a user password. Okay, so now that we have a user table and we have the fields that we want, we need to figure out which one to make a primary key. Here's an article on primary keys. So it does a really good job of describing the process for selecting a primary key. And I highly encourage you to read this article. Okay, so now if we go back to the Postgres website and we head over to the documentation, go ahead and view the manual and head over to, I believe it is data definition. And if you go over to 5.4 constraints, and if we head over to primary keys, but before moving on, you should read this section from top to bottom. It's really good. And again, I'll make sure to include all these resources down below in the description. Okay, so what is a primary key? So a primary key is a type of constraint that indicates that a column can be used as a unique identifier for rows in the table. And the syntax looks something like this, primary key, right? So here we have the table that we want to create. We have the name of the column, the data type of that column, and we're defining a type of constraint. Here we are defining a primary key. So this means that the values in product number need to be unique and they cannot be null. And this is also very important because anytime that we create a primary key, this will automatically create a unique B-tree index. And so this is why I spent so much time in the beginning building our understanding of databases, right? It's important that you know your data structures and algorithms because it makes it so much more easier learning new technologies or learning about, in my case, database design. So what is a B-tree? A B-tree is just a generalization of the binary search tree that I showed you in the beginning. Right, so this means that anytime we add an item, we update an item, or we delete an item, the tree will automatically figure out, or the algorithms will automatically figure out where to place the node. Okay, anyways, if we go back, let's go back to the Postgres documentation. And I think that's everything that I need to cover for now. Okay, so let's head back to the Postgres app. Okay, so let's make user ID a primary key, but that's not enough. We also need to specify the user ID data type. And I don't remember the syntax, so I'm gonna go ahead and bring up my, my SQL file. Okay, so I think this is the correct syntax. I am not sure. One sec. So the data type will be UUID, and then we'll call this function that is part of Postgres that will generate these unique identifiers for our users. And again, just read that article on figuring out how to choose a primary key, and you'll learn about this data type UUID and what it is. Okay, I'll just go ahead and copy and paste this. I don't remember the syntax. So the data type for email is CI text, which you can read about in the Postgres documentation. And here we are checking to make sure that the length of the email is less than 255 characters. And we also require that every email is unique. And we're also making sure that the value is not null. For the user password, we're using the data type varchar of length 128. And also we're making sure it is not null. Okay, so if I don't have any mistakes, this code should execute just fine. Syntax error at or near if. Okay, so I probably didn't do this right. Create table if not exists. Create, yeah, of course, table. Okay, this should be the syntax. So let's go ahead and run it one more time. Create table if not exists. God damn it. Okay, one more time. Okay, now what is it complaining about? User email, CI text. Okay, you know what? For now, I'll just go ahead and change it to varchar 255. And I'll leave it as is for now. Anyway, so let's keep going. So now what I'm going to do is select all the records from our users table, and the table is going to be empty. So the syntax looks something like this. Select star from users. It's working. There we go. Okay, so now that I created a user table successfully, let's create all the other tables. Okay, so now we need a country codes table. And the syntax looks something like this. Create table if not exists country codes. So we need country code. So this would be varchar 2 characters, and we'll make this a primary key. And so for country name, we'll just go ahead and do varchar length of 55. And we want to make sure it's unique and also not null. And these constraints, you can put them in any order you want. I believe this should still work. Get rid of not null. Okay, so let's run this SQL code and create the country codes table. Okay, now let's go ahead and select all the rows from our country codes table. And again, this should return, and yeah, the table is empty. Now we need to create the league table. So again, the syntax is create table if not exist league. So we need league ID. I'll also do a UUID for that and do the defaults gen random UUID. And I'll also make this my primary key. Let me go ahead and do this. Okay, so now I need a league name. That will be a varchar of 55. Again, it needs to be not null and the values need to be unique. Now here, if we go back to our diagram and look at our leagues table, we have a foreign key which references the primary key of our country codes table. And to create that relationship using SQL, we can reuse this column name and say country code. And we also need to make sure that the data types match. And here, as you can see, I forgot to update my SQL to match the data type. Anyways, and this is one of the ways that you can create a foreign key. So you use the keyword references, country codes. So you got to make sure to put the table name. And then we got to add some parentheses. And inside, we have to reference this, the primary key. So we can do this. So this is a foreign key, which is a primary key in our country codes table. Okay, so this SQL should execute without any issues. And I'll do the same as before. Select star from leagues. And as you can see, we have another empty table. Okay, so now we have to create the teams table. So we need a team ID, and this type again will be a UUID. And we'll call this internal function to automatically generate those IDs for us. And we have to make sure to set this as our primary key. Then we have to create the league ID column. And this will be a foreign key, so we need to make sure to match the data type of the primary key of this table. So the data type will be UUID, And then we're going to use the following syntax to create this foreign key. And it'll match the name of this column. I'll go ahead and execute this SQL. And as before, I'll select all of the columns from our teams table. And as you can see, we don't have any data. And then finally, I'm going to create the matches table. Okay, so I'm not going to type all this out. I'm just going to go ahead and copy and paste it and remove these comments. And I'll go ahead and run this SQL, comma. And as before, I'll execute this command. And as you can see, we have the matches table with no data. Okay, so now that we set up our tables, now we need to seed our database. But that's for another video where I'll show you how I seeded this database. And before moving on, I know I didn't spend too much time explaining the SQL syntax. And the reason I did that is because learning the syntax for the most part is pretty straightforward. That's not the important thing. The important thing are all the other concepts that have been covered, right? How do tables work under the hood? What are primary keys and how do they work under the hood? What is data normalization? Which then naturally leads us into these relationships of one-to-one, one-to-many, many-to-one, many-to-many. So if you don't know SQL and you think I went too fast, if you head over to the Postgres documentation, so maybe start here at 5.1, go through 5.2, 5.3, and then read 5.4. Okay, so now we're ready to start building our backend. Install in ORM, and finally connect our backend to our database and build a simple endpoint. Okay, so the first thing that we need to do is install HonoJS. This is the web framework that we will be using. I'll go ahead and head over to get started, and I'll use this command right here. I'll open up my terminal and change directory. I'll run the command. I'll select yes. I'll call my project directory footy, press enter. If you scroll down, you will see Node.js. I'll select that option. I'll select yes to install the dependencies. I'll select npm. Okay, so now I'll just go ahead and open my project folder in NeoVim, and I'll navigate over to the index.ts file in our source directory. I'll open up a new window and make sure to cd into my new project folder. Okay, so the next thing we need to do is install in ORM. So we will be using Prisma. I've used it in the past before, but it's been a couple of months. I'll head under products and go over to ORM. I'll head over to quick start. I'll head over to the add to existing project tab and select the relational database tab. Okay, so now we need to install Prisma. So I'll go ahead and copy this command. Okay, so I'll go back to my terminal and make sure to install Prisma as a development dependency. Okay, before we get started with Prisma, I need to explain what an ORM is. So if I head back over to Excalidraw and we take a look at this diagram, okay, and so the easiest way to explain this object relational mismatch is in the following way. So we know that our database consists of tables. And here I only created two tables, right? Country codes and leagues. Okay, and so here country code is a primary key in our country codes table, and league ID is a primary key in our leagues table. And so this arrow here indicates that country code is a foreign key, right? So here's the SQL that we wrote to create these two tables. If we take a look at this create table statement here, anytime that we create a column, we are specifying its data type. Here it is a varchar of length 2. And we have also specified that it's a primary key. So now in our Node.js backend, how can we model this, right? How can we model these tables? So typically when we're building out backend services, we have classes that represent our tables, more or less. So for example, here we can create a class, call it leagues. We can add a constructor. So anytime that we want to create a league, what information do we need? If we take a look at our leagues table, right? If we look at the SQL, we need a league name and we need a country code. So to the constructor, we'll go ahead and add name and country code. And the code will look something like this dot name, go to name, and this dot country code, that to country. Okay, and so maybe now we need an insert method to insert new leagues to our leagues table. So maybe it looks something like this. Maybe like, And finally, we do a little bit of error handling. Okay, and then here we need to send back some sort of response to the user, letting them know. Maybe we can do something like this. Message, league exists, try again. And then we need to make sure to set the status code, which could be, I don't know, let me see. Okay, so here I just quickly Googled what would be the appropriate response to send back when a resource already exists in a database. And here's a really good discussion on Stack Overflow. And just to keep the video moving along, I will go ahead and select the 400 status code. And otherwise, if we receive a result, I'll just go ahead and send, maybe we can change this to data. So we return the data and send back a status code of 200. So this is where the ORM comes into play. Okay, so an ORM will allow us to do a lot of cool things, but the main ones are one, connecting to our database. And this will look in the code something like this. So let me go ahead and, so the connection will look something like this, right? We'll have the ORM framework with some sort of connect method, and then we pass in the database details. And once we have that connection, we can go ahead and start using that connection within our code base, right? So this will look something like this, db connection dot, maybe it will look something like leagues, inserts, followed by the necessary information that we need. We only want to insert into the leagues table. And a lot of times when we're working with these ORM frameworks, we need to do something like this, like ORM framework. We need to like define model. And the code that I'm writing here, just think of it as pseudocode. We'll see in a minute how to do it the real way using Prisma. Right, so it will look something like this. So maybe, I don't know, this first parameter is the name of the table that we want to model, which here would be the leagues table. Make sure to add a comma. Okay, and so now we need to specify the column names of our table. And in this case, we're modeling the leagues table. So league ID is a primary key, and the database, if we take a look here at the SQL code, will handle the generation of the league ID column for us. So for now, I'll just go ahead and leave that out, but we do need to specify a country code, and it will look something like this, country code. Okay, and so now we need to specify the data type, and for the most part, when we're specifying the data type within our backend code base, it more or less follows the same structure that we saw in our SQL queries. So for now, I'll just go ahead and copy and paste this, and I'll go ahead and paste it over here. Okay, and so now within our class leagues, we're able to package up all the code that we need to insert a league, to update a league, to delete a league, and anything else that we might want to do. So through our DB connection variable, we're accessing the model leagues, and we're inserting a new league into this table. Okay, so let me just go ahead and quickly add league name. Yeah, this column name over in the definition of our model. Okay, and so now finally, if we take a look at this line of code right here, and let's just go ahead and get rid of this second argument. And so if we take a look at our model definition, we see that we need a league name and a country code. And so I believe this should give us an error, letting us know that we are missing this, this country code field. Okay, and so this is why ORMs are so useful, right? Because they help us bridge the gap between the objects, object-oriented programming, representing our tables in our code base, and the tables in our database created with SQL. Okay, and so now we're finally Okay, and so now we're ready to use Prisma to model our tables within our code base. Okay, and so the next thing that we need to do is run this command here. So I'll head over to my terminal and run that command. In our project directory, I'll head back over to the Prisma docs. And so this command here, it does two things, right? It'll create a Prisma directory containing a file schema Prisma. And so here is where we have the database connection as well as our schema models. And it will also create a .env file for us. And so this is where we will place all of our passwords and any other secret keys that we don't want to expose. So if I head over back to my terminal and open up that file, schema Prisma, we will see the following. So I believe, let's see, I don't know if we need to change this provider. I think it might be okay. Okay, let me head back. Yeah, also make sure that when you're going through these docs to select TypeScript and select Postgres as your database. Okay, so now we need to connect to our database, right? And so we need to open up our environment variable, and the URL will look something like this. So I'll go ahead and copy and paste this string. Okay, I'll go ahead and open up our env file. Okay, and it looks like it's already there. So, okay, so we need to figure out the username, the password, and I believe localhost. I believe that's correct. And then we need to give it the name of our database and leave this as is. So when you first launch the PG admin application, it will choose a default username for you, and then you have to set your password. So just make sure to use a very simple password that you won't forget. Okay, so I believe the default username for my database is, I think it's just Postgres. And then the password I chose, it's this one. And then you need to give it the name of your database, which we named it Footy. And then I'll go ahead and open up the PG admin application, right? So I'll go ahead and open up the databases tab, and I'll click on Footy to bring our database online. Okay, I'll go ahead and minimize this window. Okay, so everything looks good, and I'll head back over to the schema.prisma file. Okay, now I'll head over to the documentation, and let's see. Right, and here it tells you the format of the database URL. Okay, so now that we have our connection, we're ready to start building our schemas or our models. And so the cool thing about Prisma is this introspection feature. Okay, and so since we already wrote our SQL and we already executed these commands and created our tables, if you scroll down, when creating our models using Prisma, this is the Prisma specific syntax that we use to model our tables. And for the most part, it's a one-to-one mapping between the SQL that we write and then the Prisma specific syntax that we use to model our tables. And so this can also be a pain point when using an ORM, because not only do you need to learn the SQL syntax to create tables, but then you also have to learn a whole nother different syntax that is specific to the ORM. Okay, and so there are a few reasons why I spent so much time writing the SQL from scratch. Because one, it's better for you to know and understand and how to write SQL. And two, and I think the more important one, is that we can use this feature in Prisma, which is called introspection. So first, we write the SQL and create the tables in PG admin, and we don't have to worry about writing all this crap. What we can do is we can do an npx Prisma DB pool. So I'll go ahead and take this command. Okay, and so before running this command, as you can see here, I don't have any schema definitions. Okay, and so once I run this command, what Prisma will do is take a look at our database Footy, and it will take a look at our tables, and it will generate those schemas for us automatically. So I'll go ahead and run that command. Now, if I go back, we can see that we have our schemas here. So now we don't have to worry about writing the schema definitions using this Prisma specific syntax. Okay, and so now that we have our database connection, and now that we have our schema definitions, we are ready to start building our backend. Okay, I'll go ahead and get rid of this window. Right, and so before moving on, so anytime you change your tables, you need to make sure to run this command. Where is it at? Yeah, you just need to make sure to rerun this command so your schemas are updated. Okay, and so this, okay, so we're gonna skip this, but you can always come back to it and learn more about what migrations are. Right, so I'll go ahead and go to the next section. Okay, so I'll go ahead and install the Prisma client. I will run that command. Next, I'll run this command. Right, and so what this is doing is it's generating types for our database queries. And so this is nice because when we're writing our database queries, we'll be able to have a static type checking, and we'll know if there is a mismatch between what the database accepts and what we are trying to send to the database. Okay, and so finally now we're ready to start querying the database. All right, and so the last thing that we need to do is set up a couple of endpoints using HonoJS. Before we do anything, we need to create a single instance of our Prisma client. To do that, I'll go ahead and create a new file called db.ts. I'll go ahead and open that file. Now, if I head over to the Prisma documentation and look under best practices and look under help and troubleshooting, under help articles, we will find this best practice article. So this one is specific to Next.js, but we can use this code in our backend app. I'll head back over to my DB file and paste the code. Okay, so next I'll go over to this tab and under source directory, I'll go ahead and create a new directory and call it services. Okay, so I'll go ahead and open up that file, leagues. Okay, so now I'll head back to the Hono website. I'll go under get started. I'll go under guides, under best practices. So I'll go ahead and copy this code. I'll paste it and get rid of these two endpoints. Okay, and so now we need to hook up this endpoint into our application. To do that, I'll open up index.ts. So what I will do is import that new route, and it looks something like this. Next, I'll go ahead and add that route. I'll call it /leagues, and I'll just make sure to give it that leagues router. Now, if I head over to this tab over here, I don't see any errors, so it looks like everything went well. So the next thing I'll do is open up source services. So now I'll go ahead and update this function. I'll make it an async function. Then I need to add some curly braces, format it. Next, I need to do something like this. And now what we need to do is import the Prisma client from our db.ts. And all we need to do is just reference it, Prisma, import it. Okay, so if we head over to the Prisma documentation, and earlier we installed the Prisma client, and then after installing the Prisma client, we ran this npx Prisma generate. And so in practice, what this looks like, if I head back to my terminal, you can see that now I have this autocomplete. So if I look here, I have leagues, I also have teams, users, matches, country codes, and now we can execute all these different queries, right? We can delete a league, update, and so on, but I just want to get all the leagues that I have in my database. I'll just go ahead and add a return keyword here, and then I'll set the status code to 200. And for now, I'm not going to add any error handling. Make sure to save those changes. So now if I head back to this tab over here, so it looks like I don't have any errors. So this is a good sign. And then finally, the last thing we need to do is bring up our query client. So I'm using Insomnia. And what I'll do is I'll create a new project. I'll save it locally. I'll label it footy, create the new project. Now I'll add my first HTTP request. And before adding it, if we head back over to the code, I've only defined a GET request on the /leagues route. So what we need to do is create a GET request for that particular endpoint. And to do that, we'll just go ahead and add a new HTTP request. I'll rename it to just get leagues. It should be something like this: HTTP localhost 3000 /leagues. And if I didn't mess anything up, this should give us back whatever I have in my database. And as you can see, I have a bunch of data. So to see this database, what I did is I used R to web scrape a bunch of data from ESPN, and then I had to process it and structure it. And I could just quickly show you the R code. Okay, I'll go ahead and it should be under resources. Let me see. The cool thing about R is that you can connect to a database. And once you web scrape your data and process it, it's as simple as running this command here, right? db append table. You give the connection, the name of the table that you wish to insert items into. But anyways, that's for a whole nother video, and I'll make sure to explain the entire process. Okay, so I'm gonna end the video here. It was a lot longer than I expected, and hopefully you found this video useful. Feel free to gatekeep, don't subscribe, and if you run into any issues while you're following along with this video, make sure to leave a comment down below and I'll help you troubleshoot. Anyways, thanks for watching.